In our next problem, we are not required to find the limit. Instead, we are giving limit x tending to 0, x into 1 plus a cos x minus b sin x upon x cube. This limit is given to be equal to 1, and we want to find out the values of constants a and b so that the limit can be equal to 1. Now I'll give the solution of this problem in two different approaches, and whatever approach you find suitable, you can get used to that approach. The first approach is by using the expansions of cos x and sin x. Now the expansion of cos x is given by cos x equals 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial up to infinity, and sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial up to infinity. Now these are two expansions of cos x and sin x. Similarly, we have expansions for tan x also, ln x also, e की power x also. These expansions are generally difficult to be remembered. If you like these expansions and you like this approach, you can remember these expansions and try to do these problems with using these kind of expansions. But if you don't like this approach, I have a different approach for you also. Now putting the values of cos x and sin x in this question, we get limit x tending to 0, x into 1 plus a times cos x, which is equal to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus b times sin x, which is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial upon x cube. Now students generally don't prefer these type of expansions because they are little bit of difficult to be remembered. But if you can remember these, you can very easily do the question of limits or these type of questions in just 3 or 4 steps. Now we collect the coefficients of the different parts of x. The coefficient of x we get is 1 plus a minus b. Then we get the coefficient of x cube as x cube into b by 6 minus a by 2. We need not find the coefficients of other higher parts of x because on dividing these higher parts of x power 5, x power 7, etc. by x cube, we'll get a term of x, and on putting x equals 0, all the terms will get vanished. So we need not care about all the other parts divided by x cube. Now on dividing the first term by x cube, there will be a problem created because a x will be created in the denominator. So we need this term to get vanished in order to get a finite limit which is equal to 1. So 1 plus a minus b should become equal to 0 so that this whole term can get vanished and we get rid of this x. On dividing the other terms, we get x cube into this term divided by x cube plus x power 5 divided into the term divided by x cube and the further terms. Now the terms apart from this x cube term will have a power greater than 3. So on dividing them by x cube, we'll get at least one x, so that on putting that x equals 0, all the terms will get vanished. So these terms are useless and they will get equal to 0. So what we get is limit is x cube into b by 6 minus a by 2 divided by x cube, which is equal to b by 6 minus a by 2. So this is a value of limit and it is given equal to 1. So we get a minus 3b equals 6 and a minus b equals minus 1. On solving these two equations, we get a equals minus 5 by 2 and b equals minus 3 by 2. So this is the final answer of the constants a and b in order for the limit of the question to be equal to 1. Here we use the expansions of sin x and cos x in order to solve the problem. Now if you don't like these expansions and you're not able to remember them, there is a different approach also, which is an easier approach. So we rewrite the question again as limit x tending to 0, x into 1 plus a cos x minus b sin x by x cube. Now we can see that on making x tending to 0, the numerator is also going to 0, the denominator is also going to 0. So this is a 0 by 0 form of question. For these type of problems, we have a very important and a very easy approach, which is called L'Hopital's rule. This L'Hopital's rule is used for questions involving 0 by 0 format or infinity upon infinity format. This is called L'Hopital's rule. This approach says that keep on differentiating the numerator separately, keep on differentiating the denominator separately till we get rid of this 0 by 0 approach or format or this infinity upon infinity format. So here we have 0 by 0 format, so we will differentiate the denominator and numerator in order to get rid of this 0 by 0 format. So we get limit x tending to 0, x into 1 is x, on differentiating we get 1, plus ax cos x, which becomes a cos x, minus ax sin x, and this becomes minus b cos x, whole divided by 3x square. The limit is equal to 1. Now we see that on making x tending to 0, the denominator is tending to 0, and we have a finite limit, so our numerator should also tend to 0 in order to make the limit equal to finite. So putting x equals 0, we get 1 plus a, this is equal to 0, minus b equals 0. This is our first equation, which we got by making the numerator tend to 0, since the denominator is tending to 0 and we are getting a finite limit. You can see that this was exactly the same equation which we were getting as the first equation in the first approach. So we try to remember this equation, which was 1 plus a minus b equals 0. So on the first differentiation, we got limit x tending to 0 minus a sin, or rather we got 1 plus a cos x minus ax sin x minus b cos x. This was our question. Now this we converted into a 0 by 0 approach by making the numerator tend to 0. So we again differentiate the question so as to remove the 0 by 0 format. So on differentiating the numerator and denominator, again we get minus a sin x minus a sin x minus ax cos x plus b sin x upon 6x. Now we can see the denominator is again going to 0. This is 0, this is 0, this is 0, this is 0. So it is again a 0 by 0 format. So we differentiate again. We get limit x tending to 0 minus a cos x minus a cos x. So this becomes minus 2a cos x. This is minus a cos x. This is plus ax sin x, and this is plus b cos x. Divided by 6x, the differentiation is 6. Now we can put x equal to 0 to get minus 2a minus a, this is equal to 0, plus b upon 6, this is the limit, which is equal to b by 6. This is minus 3a by 6, which is a by 2, equals 1. You can again see this was again the same equation which we were getting as the second equation in the first approach. So our two equations are b by 6 minus a by 2 is equal to 1, and 1 plus a minus b equals 0. So solving these two equations, we again get a equals minus 5 by 2 and b equals minus 3 by 2 as our final answers. So here in this question, we saw two approaches. The first approach was to use the expansions of sin x and cos x, and the second approach was the L'Hopital's rule. and we got the final answer as a equals minus y by 2 and b equals minus 3 by 2.